what's good, y'all? Day 202, I think. Let's get to. Okay, I'm gonna switch things up. The graph on LeetCode is kind of hard. So I was thinking of doing just NeetCodes, but the thing is, I've done these two already, so I haven't done these. So let me just stick with these, and then maybe I'll come back to the other list. But because I do want to stick with get some graph reps, but these are kind of difficult. So anyways, let's get to it. Clone graph, never done this one, so. Give any reference of a node in a connected undirected graph. Return a deep copy of the graph. Each node in the graph contains an int and a list node of all its neighbors. For simplicity, each node's value is the same as the index the first node where val equals 1. This one looks pretty easy. Just some kind of traversal algorithm for a graph. And kind of build it. Okay. An array of nodes. Okay. A node? Kind of confused on the data type to return. Wait, let me just, well, we're only given print node. Just want to see this real quick. So it's just, okay, it's an object. Okay, so I have to return it. Well, wait, what? It's represented as an agent in an adjacency list, but we're just given a source. I'm kind of confused on what to return here. An adjacency list? So the graph is represented in the test case using an agency list, but it's not. It's just we're just given a 2 goes to 4, 1 goes to 3. Or 3 goes to 1. Okay. Okay, I see. It's represented as an adjacency, but we don't need to return that. We just return like the source. So we just copy it. Is this valid? Okay, I guess we can do this. Okay, let's basically just traverse the algorithm and just copy it. So I guess we have a source, or we'll have a source which is node, or the starting, which is a new node of node.val and node.neighbors, right? We'll have a queue, we'll have a DQ, while queue, we'll also have a need a scene, so let's do that. And we'll also add the source. Q.pop left, occur, right? Cur dot, I guess, val. We'll only add the values we've seen, right? Yeah. Scene dot add. We'll add the value. Just all the values we've seen. Or maybe what if there's a duplicate values? So I can't do that. I have to add the, I guess, I guess I have to go get the, damn, hold on. Sure, yes. Or the current, right? For every neighbor in cur dot neighbors, right? Okay, hold on. If it's not none two, if neighbor, if not cur dot neighbors, continue. Otherwise, let's iterate. Neighbor. Let's do this too. Let's actually not copy the first value. Like, let's actually just do that. Let's see. Add the node. Copy the node. Oh. I guess. Copy source, which is none. So like, okay, we have the node. I need to have like some kind of like I need to have like a double Q or something. Like Q1, Q2, right? And then like I have to like do it at the same time, I feel like. Or do I have to have one? I just need a... Okay, so like, I pop the current. Right? Current 1. Current 2. Q1. Q2. But I don't need... I don't need 2 of these, right? I just need 1. I don't even need... I guess I need 2 Qs and 2 sources, but 1 set, right? Curve 1. Then I inherit the current ones to current 2, right? So Q2 is going to dot val is equal to, oh, I see. Wait, so copy source, wait, okay. I need to create a new node, right? New node. A new node, right? Node. Okay, why is this harder than I think? Like, I think this is... So, like, I need to take the values... So, like, curve 2 is going to equal... node cur1 dot val and cur1 dot neighbors, right? Isn't that what it is? Yeah, okay, I have a bad plan. I don't really know what to do right now. So hold on. I should be iterating through... Like, I should BFS the list to... and build it as I go, no? Right, like... I'm not sure, bruh. Note that the input contains one empty list, the graph contains only one node val1. There are 4 nodes in the graph. This doesn't seem bad. I just need to traverse the graph, right? As you're traversing, create a new graph, right? Like, okay, I can traverse once to get all the values and their information. Right, and then from that, I can have a map and then build a graph. Okay, let's try that. We can do a graph, I guess, like this. I guess we can do a BFS, like Q is DQ, where node is the start, and the scene is set while Q cur is equal to Q dot pop left, graph equals the cur I guess the value, there could be multiple values, so I have to make it unique. The object itself and its neighbors, neighbors. I guess, hold on, we'll have 2 information. We'll have the neighbors and cur.val. Something like that. Then scene dot cur, right? For every n in cur dot neighbors. And dot or q dot append n. Let's just print the graph for now. Oh wait, hold on. If q dot if n not in scene, do that. Okay, if it's none, if cur I guess we could do this. If not cur, continue. This looks pretty disgusting to look at. So we have the value and the object nodes. But that's kind of weird. Node object at 7f3 what? Oh, that's 50, 10. Okay, they're different. Okay, 90. Okay, so we have our, this is cooking. And then I guess we can for every node neighbors in graph print node. I guess the items. Alright, we have the node and the value. Okay, so then I guess we call this more like node. Hold on. This is weird. Why do I have a tuple of these values when the object itself holds those? That's such a stupid. Okay, I'm actually being stupid. I don't even need to do this, right? Okay. Like, okay, we can do like a BFS and like as we go and build it, right? So yeah, okay, I'm actually cooking with that. So we'll have like a map. So I think the map wasn't a bad idea. Like, okay, wait. I think we can. What I had originally was better. Like, as you build it, like we'll have a graph. I guess new graph, right? Right, we'll have this, and then it starts with. We can have. Are the values gonna be unique? I don't know. Let's just assume it is, because we could do the node.val is mapped to a new node at node.val and the neighbors of an empty list, right? Well, I don't think we even need to put this. We just put nothing, because so as we go through the thing, new graph is oh yeah, so we take the cur dot value, right? And then I guess right here we will, for every, I guess for every and in cur dot neighbors if n not in new graph, right? I guess we say dot neighbors here. Or I guess new graph. What do I do with this, right? We go through the new graph for every n and incur dot neighbors. If an n not in this new graph. Oh wait, okay. Basically, we build the thing. We build like the adjacent, like the hash map version of it, and it will give us what we need. Yeah. So node, new node, I guess, right? Or it's like we'll do like new graph at that current val, which is node cur.val and cur.val and node dot cur.val and cur.neighbors, I think. Or something like, okay, like we have to, okay, I see what we're doing. So we're trying to, so the new graph and the old graph, we have to iterate at the same time. So this is the first element, right? This is kind of like our queue-ish. This is our first element. So we need to get the first element for this one by, or getting the element traversing that we were trying to traverse. So it's this value, and to map it to the new graph, we have to as current new, it's like cloned cur, I guess, which is cur.val, right? But at the new graph. So for every neighbor in cur.neighbors, right? If neighbor not in new graph, so this is where we create it. Okay, let's say this neighbor isn't in our new graph, then we should add it to the thing. So we can say neighbor.val in our new graph, right? Which will equal node of neighbor.val with, we'll start with an, I don't think we need to add this. We don't need to add that. With an empty list. Then let's say after the neighbor, let's say they're already in the thing, then if neighbor not in the new graph, let's we add it, and then even if it was there, we should add this cloned cur dot append, dot neighbors, no, clone cur, yes, dot neighbor dot append the neighbor, yes. So we should add that to the clone cur, right? then yeah, we're done. And then return, we need to return node, and we can just return the new graph at node dot val. This only works if the nodes are unique or the values are unique, but hopefully, oh. Okay, hold on. I have to press something else. Okay, hold on. What is this none type has? Okay, hold on. That's probably the third test case. If not node, let's return. Node 2 was copied, but a reference to the original. No, we need to make a new one. Isn't that what we're doing? Making a new one? New dot and then making a new, yeah. Oh, no. I can't add the neighbor directly. I need to add node dot val, and what about their neighbors? Well, that's something that should autocorrect itself. Yeah. Oh, wait. Okay, we're actually already checking. Okay. Let's say this neighbor was not in it. We'll create it. And then now we could just append new graph neighbor.val. Yes. Which is the copied version. New graph neighbor. Yeah, we could do that. What? Must return a copy of all the. That's what I'm doing. Because if it wasn't in the graph, then we'll make it. If it is, then yeah, if the neighbor is not in new graph. Oh, no. If neighbor.val. If the neighbor.val, yeah. What? That makes no sense. If the neighbor.val is not in the new graph, make a new node, right? And then we'll add that to the neighbors cloned cur dot neighbors dot append the node, because we want to keep nodes in the neighbors, right? The new graph node dot val, yeah. You must return a copy of all the nodes in the. What did I get, bro? I guess it didn't. It wasn't. It's not like what. It should be the new. Like this is a new one, right? I'm creating a new one. Cloned cur equals new graph. Yep, at that moment. For every neighbors in the current neighbors, if the neighbor dot value is not in the new graph, then the new graph at neighbor dot value is equal to node neighbor dot yes. Otherwise, but it's not even otherwise. Then we'll add that to. We'll add it to the list, right? What am I missing here? I'm trying to understand what I'm missing here. Passing the second one, but not the first one. Oh, it makes sense. The first one is not, because I'm not getting it copied correctly. We must return a copy of all the nodes in the original graph. That's what I'm saying. Let's print new graph. And then 1, 2, 4. Oh wow, I think it might have not worked. I'm noticing like we're not even getting 1, 2. We're not even adding all the values. There should be 1, 2, 4, and 3. Where's 3? Oh my god. Neighbor. We need to add this q.append neighbor, bruh. Yeah, freaking, oh my god, didn't do the BFS race. Alright, we're coming up on time. So anyways, thanks for watching. I'll see you guys tomorrow. Peace.